Conceptual framework for implementing lane defilements in highways using Internet of Things or IoT. The tentative idea or views are presented by Dr. Swetha and Ms. Renuka Devi. So a very warm greetings and hope everybody is safe, and we wish for all of you for being safe and for your good well-being. So just to kickstart with our views on our topic today, which says about conceptual framework on land defilements. So it's more about lane defilements. Lane defilements is more of technical word, but when we break it down into commonality, it's like violating the traffic rules, getting into lane crossing, basically using vehicles, and leading to a high range on the graph of increased accidents, mortality rate, and deaths. So how do we reduce that in a country like India? So we are like on the global map or on the surveys, we top around like say 72.8% according to Gartner's on Indian surveys. Most of the accidents do happen because of lane defilements and not adhering to Indian traffic violation policies. So we thought that how can we give an economical solution using basic IoT sensors that can do like a giant leap of broadcasting informations and putting a penalty hook by whenever there is a land defilements. So why IoT? So and why this particular technology is that we found the technology to be more simpler and could be perceived by a lot of common people who when we implement this and bring into existence. So why not artificial intelligence or why not the high-end technology? Mostly we are looking into not bringing up or pumping more of monetary values. So monetary funds that involve and the implementation facets of it. So we thought that IoT or Internet of Things are much easier to perceive, simpler, and can be put into a mass production system on implementation part, wherein a lot of us could be benefited and we could at least reduce the 72.6% or 72.3% on the random of accidental rates and increased mortality that happens because of lane violations. Now, when we talk about Internet of Things, there are a lot of broad spectrums that is available. Now, broad spectrum uh, of definitions that is available. Typically, IoT works through real-time collection of data and exchange of data through IoT components. So a lot of us know how IoT goes on. It goes on with smart devices, IoT applications, and of course we would be needing a graphical user interface. And we're going to implement all these three components in our work and try to come up with some kind of an reliable solution that could reduce the violation of lane defilements. So that's what we are exactly trying to aim, mostly concentrating on economical conditions. Now, there is a lot of definitions that IoT refers to collective network of connected devices and the technology that facilitates communication between devices and a network itself. So there are a lot of and it basically works on sensors, and there are n number of sensors doing doing like a great job on accessing the information and trying to exchange the information. Now a network, so it's interrelated. So interconnected objects that are able to collect and transfer data over wireless network without human intervention. So this is what IoT actually does. So it takes the data, it gets interrelated, and it persuades with a wireless network, and if wherein you don't have any kind of human interventions. So a thing could be anything now, Internet of Things. So a thing could be anything, which is like a medical device or a livestock or a solar panel or an automobile sensors or what we are talking about today, a land defilements. So we are going to talk about a thing called vehicle. So how am I going to apply my IoT fundamentals or principles on controlling vehicle overspeeding or delineating the speed? So this is what we're going to talk now. Today, like there is IoT is in all prospects. So it's in business, increasing revenue, reducing the operational cost, improving the proficiency as well as the efficiencies. So all the businesses are the economical businesses or the technicality is demanding for technology that is going to be deployed seamlessly, and the workflows can be visualized, and we can actually see how the process is going on. So this is what exactly we needed in order to control or in order to bring back everybody in getting into the in not barging in with the violations. So that's what we're gonna like talk about, and that's what is the prototype talking more about. Right. So, what's this lane defilements? Now, lane defilements or lane crossing or lane prohibition. We can. These are some of the terms in which we could be talking about. So, when we talk about this, if you observe here, you do see some lanes over here. Now, these lanes are how in India we divide is that heavy motors and less duty motors like cycles and bikes and all these things go in one particular lane especially in the highways, and the lorries, the heavy vehicles, the tractors, the motor automobiles, these are into another lane. Now, in the highways, now what happens is that there is a possibility of delineating this. What's delineating? Instead of a lorry going in the specified lane where the lorry has to go, or the truck or the automobile, you see a bike or a three-wheeler or a two-wheeler trying to get into the lane just because the lane is empty and the two lane or the three lane wheeler lane is overcrowded to get ahead of another vehicle. Now, this over a period of time may cause um, uninclined, um, uninclined accidents or not intended accidents that could be life threatening. Now, in Western countries, especially in European countries, we are having certain prospectus, or we also call them the prospectus in terms of how these automobiles are working through. They do have their wild policies and rules of how to travel or how to drive or ride in between the lanes. So most of the European countries or most of the Western countries, if we clearly observe, we would have seen in a lot of movies or web series, if we are able to relate, you will never see that there is you will never you will always observe that there is like around 2 to 3 meters as specified by uh, the country's protocol. There would be a certain limit of gap that is one behind the other of the vehicle, and they go in that particular order. So you wanted to go ahead of another car or you're in emergency, you are actually allowed to take a different lane on a requisition. On a request, you will be allowed to use the lane. Otherwise, you need to maintain a pace between one car before and after that you are riding or driving. So this policy is the best one, which there is a lot. You do not have this lane defilements in Europeans and in European and Western countries, but this is not as such when we talk about our Indian roadways. So in Indian roadways, we have the speed delineating or overspeeding, and there is something called a switching between lanes without prior notification, like not even getting into their alarming systems that the bikes or the cars or um the motor vehicles do allow you to go ahead and use it. And this is what is like bringing up this issue ahead with the overspeeding. Now this has to be reduced. In order to reduce this, we have come with a protocol, or we have come with a prototype that will allow us to do this. So we have proposed a system which will basically allow you to record what is happening in the lane, and every lane will be having the system along with the broadcasting system. And we have an extra feature called penalty. Now this penalty only will be used when we are not observing the vehicle adhering to the policies or the violations. Even after cautioning, the penalty system will automatically lock the wheel systems of the vehicle. So until you rise out to the penalty, this will not be released. So this is how we've planned to go about with this particular prototype. So what are we trying to exactly relate? Now there is this system called as PulmoTrack Module. Now this is very very crucial, or very popular in neonatal wards or neonatal cases, wherein the baby where the heart rate is less at the time of delivery, or when the baby is born, or when the infant is born. So we can monitor the heart chest count, which allows us to tell whether the baby is having, or the infant is having, ample heart rate or the breathing rate. Now this happens with this particular tracker. So now this is the exact strategy that we are going to apply on the vehicles to track the speed and to notify their Jeep. We are also using global positioning system. We are capturing the data, we're broadcasting them, and we are giving an intimation to the vehicle rider or the driver, to tell them that they are exceeding the speed limits and they have to come in control. Now this will also alarm drivers or heavy automobile drivers who who drive their vehicles in the late hours, especially on the highways. So this is the exact thing that we're going to follow, but this is not going to be on an uh, moving. This is not going to be on a life-oriented object. So this is a life-oriented case. Now this is not occurrence of a life-oriented. It's going to be on the vehicles. So when we talk about internet applying on a thing, we are talking about vehicles. So we've got these are the crucial components that we are going to be using. So we are going to be using a CLD, which is control lane driving, and we are going to use an ASCS, which is automated speed control system. Of course, we will be needing an high-end technology of IoT sensors, such as Zigbee technology, ultrasonic sensors, and a GSM. And of course, we need to construct an application. So these are three modules that we will be using to come up with the prototype to avoid overspeeding. Right. So generally, when we talk about this, this is one of the prototype that is used in European countries. So it's by IBS, and now this is the strategy to monitor the overspeeding. They set the speed, and a satellite captures this and conveys it to the local surroundings of GPS monitoring modules, and that's how the speed is sensed and the driver is asked to stop by the traffic adherence. So this is one of the European monitoring system. Now this is what exactly we are trying to talk about in terms of our prototype, which is with a combination of CLD and ACS. So now the CLD and ACS, now this is like a protection competence. It's cost effective in highways, and it uses advanced techniques such as sensing, encountering, analyzing, and connecting, as well as regulating and administrating any type of transports. So we are going to pick up all kinds of transport, including two-wheelers, three-wheelers, four-wheelers, that are in different lanes that it is going to occupy. Now, there are various components that we would be using to control lane defilements, and we will also be discussing few of the other things as well in terms of monitoring this. So when this particular CLDS and ACS, we have planned for this pattern, which will be having a Zigbee transmitter, and this will be placed in wherein the data or the speed limit that has to be captured. Now, this is separately done for a two-wheeler as well as for a four-wheeler. So, for a two-wheeler, we would be having it over here, the Zigbee and transmitter, Zigbee transmitter, and for the four wheeler, we would be having it. So ultimately, what we are talking is that we are having a unique lane defilements for a two wheeler as well as for a four wheeler. So this is how it has to be planned. Now, four-wheeler will have a Zigbee receiver and an Arduino to compare the speed, and once the speed exceeds, the vehicle will be jammed automatically. Now, when it is jammed automatically, the driver or the vehicle owner has to pay the fine in order to release the jam. Now, this jam will happen using ultrasonic sensors on the wheels of the brake limits. The same thing would happen with a two-wheeler as well. Finally, we have a GSM network that would be getting the SMS to the registered phone number, as in a violation has occurred, a penalty is to be paid in order to release the jam. So this is the exact understanding of the prototype. Now, the conceptual block diagram is to give an idea of how we are using this. So the main components of the block diagram would be the Zigbee transmitter. Now this is placed in between the lanes, as I already demonstrated. Now Zigbee is going to be inexpensive, protected, and it's malleable, low power consumption, and it's simple is to with the infrastructure. We'll then be using something called as an ultrasonic sensor. Now this ultrasonic sensor is for sensing the distance, velocity, and the direction in which the annotation happens. So this ultrasonic sensor will work on the principles as in to record the speed that has been used by the vehicle separately, and to decrease these sounds, because there is going to be a lot of vehicles that is going to come at the same time. So we need to monitor individual vehicles. So I need an ultrasonic sensor to calculate the sounds of different waves that happens between the vehicles, and to detect the distance as well as to check the obstacles in order to understand in which lane it is going to get into. And then we would be using an Arduino. So Arduino is again an open source platform. So I would be using an Arduino IDE for calculating and programming through the GUI. Again, a GSM module to get the 80 commands, as well as to have a GSM module to accept, direct, or remove the SMSs accordingly to how the penalty is charged. And we can also use a voiceover on the same. So we will be having a graphical user interface to have the violated data and through which lane it has been happening, so that we can get in with the future speed limiting and all these data to be achieved through penalty. So this is the exact work procedure of the prototype. Well, this particular prototype would allow us to send and receive messages to the rider, as well as the person who's going to ride the vehicle or drive the vehicle. Now, speed of the vehicle is very, very important So it is like violating or trying to cause too much of death rate because of accidents, hit and run cases. So all these things has to be brought to an prevention method or prevention block, so that we do not increase the serious part of driving a vehicle. So this particular model is a very simple model and doesn't involve too much of cost, and it's quite easy to implement as well. So reducing accident rates in highways is something that is of concern, and we would try to implement this in order to achieve at least one third of a reduction in the actual survey rate. And the locking of vehicle system is something new that is not available in previous studies or previous work. So this is something that we are trying to achieve in terms of jamming the vehicle through an Arduino code. So yeah, thank you. Hope you liked our views about this. Thanks.